Dan.
Hi, Pete.
Nice to see you again.
It's very nice to having you here at Ajatec. Hi.
Thank you. Let's start with the first question. Can you please tell us a bit more about Ajatec? We know it's one of the pioneering companies in Finland or even in Nordics in 3D printing and additive manufacturing. Maybe a short background who you are and what you do.
Well, yeah, sure. I mean, even though the brand is quite new, Ajatec was launched in 2018. The experience of the company is much longer. So we already in the 1990s we were part of Electrolux Group and part of their Electrolux rapid development team. And we in the 20s we were part of Alphaform, who was a German company later bought by the American Protolabs. And we even had a short stint with the Protolabs for a couple of years before we then, via an MBO, spun off as Ajatec. So we have been involved in 3D printing already from the Electrolux time, because Electrolux was the big and the first to install a stereolithography machine in Lilla Essingen in Stockholm. And our people were also involved in that installation. So we have been involved in this business all the way from the beginning, you would say.
And nowadays you have quite a few technologies in-house.
Yeah, we run about 12 different industrial 3D printers, and they are representing 7 different techniques at the moment. So quite a few too.
Yeah.
And that's one of the kind of the advances and advantages with using Ajatec also, and our customers kind of like that, because they have one source of contact and they can then choose, and we can choose the material and the technology which is best for their parts and their geometry, because all of these techniques, they have their benefits, but they have also maybe not so good things. So they are very suitable for some test purposes or some parts, some type of parts, but then generally not that suitable for other ones. So we have the alternatives to choose from.
One question came to my mind about the challenges nowadays. Mm-hmm. What type of challenges you face in terms of growing revenue or staying profitable?
Well, in the beginning, in the 90s, it was all about kind of manufacturing the part. So if you could manufacture it, that was enough, and the price pressure was not that high. Obviously now we have a lot of competition on the market or in the market. Also the customers are more accustomed. They have also invested some in their own office printers, for example. So the price pressure is much higher, and that means that you have to optimize your processes, and you can't use the same amount of time to finish the part as we did 10 years ago. And that automatization and that digitalization is something that you have to do, and that's one of the challenges to be able to do that. Obviously there's also challenges which is not, as a service bureau, we kind of face in the price point of the raw materials, the machines, etc. But that's also something that is there, because there's competition in that area as well. So we expect that price is coming down on the machines, and let's say at least in the produced cubic centimeters per hour, the price per cubic centimeters is going down. That has to be, and that has to happen if you want to go into additive manufacturing. That's something of kind of the challenges today.
So basically when you if you focus on streamlining the workflow from file preparation to printing and to post-processing, that's something which needs to be focused on nowadays.
It needs to be focused on, and it needs to be addressed. And that's of course something that we as a service bureau and a producer of the parts, we can focus on that. The price on the raw material, etc., that we can't do anything about that. That's what the market is, and then we have to find the right customers for that price level, and we have to optimize the process. That's kind of our challenge and our task also in this value chain.
Next, we are going to see the whole production flow starting from Magics, going to 3D printing with HP Multijet Fusion 4210, and then post-processing with DyeMansion Powershot C. Okay, so we came downstairs to see the first part of the whole process, and this is file preparation, and Dan, you are using Magics to prepare files for HP printing.
Yeah.
You have been using Magics for quite a while now, from version number 7, right?
Yeah. Well, I think it was something like 7 or 8, or at least it was a long time ago. As I said, we've been in this business for 20 years and we've been also developing together with Materialise in using Magics. I have to correct you though, I mean, this is not the starting point. The first starting point for us is actually when the CAD files comes into our sales organization, and also the sales team is using Material software and the conversion of file formats, etc. But this is obviously the starting point then for the production. So we have to prepare the run, and this is all happening here in our work prep. The first nesting modules weren't that efficient really. I mean, we were doing a lot of manual work there, but today I think the first version is always done with the nesting modules and the sintering module, but then the optimization and the final kind of settings still needs some manual work. But for sure it has made the process much more efficient than it used to be when we do more manual work. We have the same, I mean, of course, in the powder bed systems, the nester is very important, but also in stereolithography, Magics is much more faster today, and it's not, part of it is of course Magics and how fast that is, but it's also a lot of with the interfaces and the conversion of the file formats and how you correct and fix the modules, so also fixing the possible errors that there are in the CAD files. That's today it's very seldom that we have any errors in the geometry, part geometry anymore.
You mean that if you receive file from your client, you are doing file corrections in Magics before printing?
Almost every time. If you convert from IGS or a step or another format, obviously 3D printing is using STL as the file format. So you will have some errors from the conversion, and that is now automatically fixed in Materials in the Magic system, and that's much more efficient today than it used to be 10 years ago, of course. And so in file conversion is also an area where it's a lot faster today, and it's much better quality. So that's also very important to keep in mind when we talk about the process and being efficient on the process. Slicing in stereolithography system is much faster today, and the quality is much better. So it's on all levels, and that's one of the things with the digitalization and automatization. You also have to keep up with the development. You can't be stuck with an old system because it's just not efficient enough. How big builds you print with? How many parts per build usually? Or is there any number? Not really. I mean, it can be everything from, as we are a service bureau, and one of our competitive advantages is the kind of speed of delivery. So our customers expect parts in a couple of days. So it's obviously a question how much of orders we get in those couple of days. So some of the builds are just partial builds, and some of them are full height builds. But it doesn't matter that much because it's more a question of how much can you put into one layer, how efficient, what is the kind of percentage utilization rate of the volume. Nesting, exactly. So even if we just build a half build, if it's nested, optimized, and you have a good utilization rate of the volume, it's equally profitable for us. But obviously, if you're just printing one part, it doesn't really make sense starting up this process for that.
Not as a service bureau.
Not as a service bureau, no.
If we think about the product life cycle, how do you see nowadays, where do you see the most orders coming in for you as a service bureau?
Well, from the revenue point of view, the biggest part today are still in the R&D and in the need of testing and prototyping. And that might also be a part because that's our legacy, that's where we come from. So obviously our customers ask that. But if you look at where the biggest growth percentage are today, that's from the additive manufacturing. So that's from producing parts for manufacturing. And when we look at design for additive, it's more of adding functionality, maybe combining geometries that are later to be produced as two separate entities, and they can be combined in one with using 3D printing or additive technologies. And we see that happening, and that's fine. But if we look at kind of design for additive with the intention of topology design or geometries that can't be produced with any other techniques, we don't see that happening very much. We see a lot of marketing in that area, and we see mechanical design bureaus, industrial designers offering that service, but today we don't see that very much, especially not in plastics. But maybe that's a little bit different actually in metal as well.
Now let's move to the production area and see HP Multijet Fusion 4210 in full production. So now we are here to see the printing start, and machine is running on the background, and maybe a couple of questions about the HP technology and reasoning behind your investment decision. Why did you buy this machine, and how do you use it nowadays?
Well, I would say the main reason for looking at the HP technology was really for kind of manufacturing purposes. So when we talk about additive manufacturing, it's not that much for prototyping, even though we do also prototypes with the HP, but it's more of a serial production, and that is the target, and that's something that is happening, and that was the reason for HP technique. Obviously, we already had stereolithography, we had laser sintering, we had color jet printing, we had carbon filter, etc. So we had a lot of techniques, but the multi-jet fusion has some good strengths with it. Of course, it's not a laser technology, but it's still using heat and a chemical reaction, which means that the part is compact. It's not a porous part, it is a compact part. It also has some interesting material properties. It's a little bit higher temperature resistance. So there were some technical reasons also from the parts point of view. It was a broadening the offering we have. And then capacity, throughput. So it's a very fast machine. So when you do a lot of cubic centimeters per hour, that's always a good thing for a service bureau, and that. So all these 4 reasons together was behind the investment decision.
Yeah. Okay. What type of applications you see your customers printing? What type of needs you see, and how is the machine used in that sense?
One of the challenges being a service bureau is that we don't actually know the application where these parts are going. So we just do kind of plastic parts or mechanical parts for them. A lot of them, though, we know, of course, the customer, they are in electronics and different kind of covers or assembly parts. Typically for MJF, if we compare with the other techniques we have, is that the volumes, the amount of parts, similar parts, are higher in the HP technology than, for example, in the stereolithography. So it is definitely a technique that is more for production purposes.
Hi, Patrick.
Hello, Petteri.
And nice to see you again.
Nice to see you too.
Great to have you here, and I thought that I would like to ask you a couple of questions of your new product. You work as a project manager in Ajatec.
Yeah.
And I heard that you just launched your first new product.
Yeah.
Can you please give me some insight about it?
Yeah, it's our first product, like in history of Ajatec. In the past, we are just providing 3D prints and rapid casted parts, and they were prototypes and end products to our customers. So this was our first own product. So I am proud as a project manager.
Okay, so here we have the actual product.
Yeah.
Looks nice.
It's very nice. It's our product, so it's nice.
So I'm interested to hear that you said that you sent a few of them to your demo clients in pharmacies.
Yeah.
What was the feedback after trying this out?
Maybe I will start with the positive feedback.
Yes.
But the surface finish, surface quality, it's pretty nice. So it's very comfort on skin, and the whole structure is very light. So you barely notice that you have it.
Yeah, looks good. And I heard from your CEO, Dan, that you have streamlined the process of producing these, and you are using Magics for file preparation or build preparation, and then push it through the HP multi-jet fusion printer, and at the end use DyeMansion Powershot C to post-process. How do you see the whole process suiting your needs? Is it effective or fast enough?
Yeah, I think it's effective because we have the multi-jet fusion 3D printer and we have the Powershot C. So I think that's it. The flow is efficient with these products. Of course, you need to optimize the runs and the nesting should be optimized, so that's cost effective also. But yeah, it's very automated.
And last, we will see post-production with DyeMansion Powershot C, fully automated post-processing system. All right, so now we are here in post-production phase of the parts. I would like to know, how did you post-process the parts before the automated post-processing equipment?
But it was a very manual process. So we used a shot peening machine, but there was always a person, finishing the part and shot blasting it, and that was very time consuming. So that was the reason for the investment into the Power C, and that's I think that's one of the best investments I've done in the last years, definitely, because that has saved us something between 2 to 3 hours per day in just shot peening those. A lot of parts now we just put them into the machine and they are ready for shipment straight after. So that has been a great machine for us.
Well, that's good to hear. And basically you can get the parts out from the machine in around 10 minutes before or after you put it?
Yeah, about it. And if it's a normal part, a normal plastic cover or something, it's just ready for shipment straight away. So if there are some small details, kind of screw towers or thing, you might have to open up those small holes, but it's just a fraction of the hours that we used to use in the shot peening.
Okay. And how many parts you usually put inside the cycle? Do you have some average?
I don't have any average sum. Basically, we just do the whole kind of run and we put it into the machine as such.